All right, this is our first AP Physics free response question that I've had you guys do on your own. These are pretty challenging, and so I want to walk you through the different skills involved in answering these questions. You can see that this is from the 2016 AP Physics test, so this was an actual question that other students had to answer. You can see this is the third question on the test. We'll probably go through all the other ones at some point throughout the year. This is one that focuses on motion. This one is worth 12 points and it's suggested to take about 25 minutes. There are always two questions that take a little longer. Hopefully this video isn't quite that long since I know what to go through for you, but just know that there's going to be a lot of time for you to think, diagram through these answers, and really figure everything out. So take all the time that you need. First thing you want to do when you see this problem is just look at the diagram, see what it's telling you, and figure out what you need to know. So it looks like we've got a cart. I'm assuming M is going to be the mass. It's on this inclined plane here. We've got theta as our angle, and then we've got D. Looks like that's the distance between these bumps. So this cart's going to be going down this track and hitting speed bumps along the way. Now when we look at the introduction to the problem, looks like that's exactly what it's telling us. We got the angle theta, bumps are evenly spaced, so it should all be the same space. The track is much longer, so it's not just this portion, but it's a much longer track. The cart has been released, and we're now reaching the 40th bump. So they're basically saying we're right in the middle of the track. It's been going for a while. And here's the really important part. Let's highlight this. So it looks like the cart's average speed between successive bumps no longer increases. So I'm highlighting that because that looks like a pretty important detail. Everything else is just kind of describing the diagram. But this right here is something we want to know. The average speed between each successive bump is not increasing. So it's reaching this maximum value right here, this average speed, the average. So the time between each bump should be the same. Now, when I first read this, I was confused and thinking it was going the constant speed the whole time. But as we know, if something's going down a hill, it's going to be speeding up. But what we're saying is, even though it's speeding up, it slows down every time it hits a speed bump, and so that all evens out. Now from here, let's look at the graph it wants us to draw. In the figure below, we want to sketch the cart's velocity v as a function of time from the moment it reaches bump 41 until it reaches bump 44. So let's do exactly what we were just talking about. We know it's going to be speeding up, and then it hits a bump, and then it's going to go down. And it's going to be speeding up, and then it's going to hit a bump, and then it's going to go down. Maybe not quite that fast. And it's going to be speeding up, and it's going to hit a bump, and it's going to go down, and should be speeding up, and just continues. Now, hopefully those lines would be a little straighter. Obviously, they don't expect it to be perfect, but with the pencil, you can probably draw better than that. Then, over the same interval, draw a dashed horizontal line, which is V average. So we know that is constant, so it's got to be somewhere. If it's average speed, it should be somewhere in the middle. I drew that a little low, but we're going to say that's the constant average speed. Okay, now let's switch over to writing. Now we know that they are increasing the distance, so we want to know what's going to happen to the maximum speed. Let's think through this. We know that if the distance between bumps increases, the car has more space and time to accelerate, so it should reach a greater maximum speed. You may think that's a lot to explain for such a short answer, but you really need to give all those details and show all the steps of what you're thinking. All right, next question right here. The bumps return to the original spacing. The track is tilted to a greater ramp angle. Now, is the speed going to increase or decrease? I think once again, we can tell right away. We know that if it's a bigger incline, it's going to increase, but why? We need to talk through as much as we can. I know it says briefly, but it's probably going to be a couple sentences. So we know with a greater angle that there will be a greater acceleration due to the increased force of gravity. Right? We're feeling more gravity, and we'll talk more about that when we get to forces, with a greater incline angle. This means that the cart should reach a greater maximum speed. All right, that's all for part C. Now there's still 2 more parts. Remember, this was a longer one. So part D, sometimes we just try to create an equation that is intuitively expected to be true. Then we can check the derivation of this equation. So someone comes up with this equation. The average velocity is c, some positive constant that we don't know, probably just to mess with the units, m, which is the mass, g, which is our acceleration from gravity, sine of theta, which is the angle of that ramp, and then d, which you remember is the distance between bumps. So the student wants to test the equation. They vary the mass m and see what happens to the cart. Now, looking at the equation, we know that when m increases, v increases. And if you're just jumping right in, not thinking through, you may look at that and say, hey, when v increases, or when m increases, v increases, looks like we're correct. But there's 2 big problems here. What if m decreases all the way to 0? The velocity is still a non-zero velocity, so that doesn't make sense with this equation. They're not directly proportional that way. Another reason we can tell they're not directly proportional, here, if we have a mass of 1, we have a velocity of around 1.5 meters per second. If we have a mass of 2, based on this equation, when m doubles, v should also double, but we don't have this slope consistent with that, and so that's not totally working the way we expect it to. So when we double the mass, we don't have double the velocity, which means that there's something missing in our equation. So we're going to say no, and then I'm not going to write it out because you just heard the 2 reasons that I gave there. Last question about this equation. There may be a problem with the equation for other reasons. Does the equation make physical sense? So does it make physical sense? Let's think about what's happening in the physical situation. We already talked about m. Let's talk about g. We know that when g goes up, v should go up as well. More gravity, more velocity. That looks like it lines up. When theta goes up, that means sine of theta also increases. Bigger angle, bigger velocity. That also seems to make physical sense. Here with d, d's on the bottom of the fraction, which means when d increases, v is actually going to decrease. And that is inconsistent with what we saw. We talked on the last page, that was our answer to part 2 here, or part B, that if the distance increases, then v should increase. And so that's what I would explain here on part 2, that when the distance is increasing, velocity should also increase, and that's just not what we see in this equation. So that's one other problem with this equation. I know that's a lot to think through. Remember, you don't have to get every single point, but you need to try to think through as much of that as you can. Once you've got those answers, we've always got these scoring guidelines you can check. Hopefully my explanation helps you understand a little more of this reasoning, but I'll let you go through and read these step by step if you want to see more of what they are looking for on this question. There's also some examples here. You can see an example of a good student. This student, the first one's always a perfect score, a near perfect score. You can see their graph, detailed explanations for each of these questions. You can see the next person didn't quite get their graph all the way right. They lost a point or 2 here or there, but they had pretty good answers, and they may have been thrown off by a few questions, and then the last one will always be one. You can see they give no explanation there. The graph is a little weird, and no explanation there. So they're always going to give you those examples, and you can even read more details if you want to know exactly which score they would have gotten. You can see the first student did get all 12 points. Remember, you don't need to get all 12 points. Even getting 7 points out of 12 is still a really good score on the test. So feel free to come check this PDF out. Remember, that's always posted on Canvas if you need more explanation there. If you still need more help, feel free to come talk to me.